Hello, for this problem, we're given an electric field, and we're trying to use the Phasor equation to find out what the value of each field is. We will get started by looking at the Phasor equations. The Phasor equation is defined in the book as the equation 5.18. It's basically a representation of the Maxwell equations by substituting in the spatial vectors. The reason to use the Phasor equation rather than the Maxwell equation because it's easier for algebraic manipulations. We have the E field given, so we can use this equation, which is by calculating the curl of E in order to find the value of each field. And we can start it by calculating the curl. First, we can put everything into this determinant, and we'll start by looking at the x hat terms, which is composed by the derivative of y on this cosine term and the derivative of z of this 0, which is essentially 0, followed by the y hat term, which should be the derivative of x on this cosine and the derivative of z on 0, which is also 0. Keep in mind that when we're expanding the determinant, the second term will always be negative. And lastly, we can do the c hat term, which is basically 0, right? And after simplifying everything, this is what we have. And the first term is by doing the derivative of y on this cosine term, and if this will give us negative 6 as the coefficient because it was 2 times 3 is 6, and the negative sign comes from doing the derivative of cosine, which returns into negative signs. And for this term right here, the coefficient would be a, and we first get negative a by multiplying 2 with negative 4, and also the derivative of cosine will also give us another negative sign, so they cancel out, which give us a positive a. And this is the term after with simplifying the coefficients. And after this, we can move everything except for the h field to the right side and isolate the h term. You can see here we already have this negative j right here. However, the question specify the field has to be a real quantity, so we need to somehow get rid of the negative j. And we already know that negative j is equal to 1 over j, and then 1 over negative j is basically the 1 over 1 over j, which gives us j at the end. So plug it back into the equation, we get this is what we get. Now we need to get rid of the j, and we can do this by realizing j is a positive 90-degree phase shift. And if we have a sine term, sine whatever, plus a 90-degree phase shift, we're gonna get a cosine of the same term. So in here, the sine term returns into cosine term, and I just take out the negative sign inside the parentheses, so we have positive here and then negative here. So for the last step, we're trying to find out the product of omega and mu. And in the E field that was given, we already know that omega is equal to 10 to the 9th. And because of the problem says that the medium is a non-magnetic medium, so mu is equal to mu naught, then is equal to 4 pi times 10 to the negative 7. And once we multiply them together, we're going to get 400 pi, and then we can plug it into the equation, and this would be our final answer.